אוקיי, good night everybody. נדבר באנגלית, כמו בשאר הקלטות המיקרוסקופיה של הזמן האחרון. So this will be a microscopic examination of 3 slides. Again from the 3 like yellow, by now yellowish, yellow burned containers. So I decided like, to actually record this examination because I started to look on one of the 3 slides and it's already, very interesting by the fact that we have very large amount of what is considered very large neurons. I think that, if I'm not mistaken, this is actually seems to be like the slide that, like a record, like in that aspect. Like, I don't think that I've ever actually, featured in this channel, like, or any other channel for that matter, a slide with such a large amount of big neurons. And and it's obviously they're not that, like you will watch it in a second. So also should say that it was taken from a steady state, not after burning and after So and they don't look like that. Then it's not. It doesn't look like a that-rich environment. Like it looks like a steady-state environment, which is what it is. So it's interesting. No, part of the thing is that just that, I didn't stain it because I don't have stain now. I diluted the remnants of the LCNY with more water, and so it's so watery now that I cannot use it. Almost cannot use it. In a meaningful way without diluting, tremendously diluting the mixture. So just removing the stain, just give it a more dense mixture. So in a way, it's kind of maybe it's not such a tremendous improvement compared to what we've seen in the previous slide that was stained. Partly, depends. There was before the dilution, after the dilution. I might still use the dilution, the diluted, the highly diluted LCNY, maybe for the Colosseum, if we get to it, which will probably be done again not on a microscopic slide, but on in a petri dish, which it can contain much more material. Although it should be said that the way that we've actually went with this thing is is not using the grill because it was just it proved difficult that setup to do it without overflow. I wanted to avoid overflow because we lose so much material in neurons. So instead I opted for this kind of thing when the lower kind of when the mixture in the containers, the yellow containers, is not burned at all. Maybe just for a second or something. I lighted. No, it's not true. It was burning, but for a very short, very low flame for quite some time, but very low flame, like a candle, or a little bit more than a candle, to produce some inside heat, but not much. Mostly, it was just heat from the hot plate, which is not considerable. And also should be said that I used the energy transfer way, which is quite standard by now, which means that all the smaller ones like the candles, the Ner Neshama Katan, and also the 2 hookah heads, they were all lit for quite some time. And the mixture is a Nero-rich mixture, which is that I placed inside the candles from the many containers that I still have that were obviously on the hot plate. And at some point I took some of the material from the yellow containers, from the big containers, the one that we actually sampled, and put it in the burned ones, the Ner Neshama ones. The idea is that you transfer energy that way. That the neurons, they are matched. This is statistical, but statistically, if many neurons are created inside the yellow, the big containers, when they are created in pairs. So at least some of them will be actually moved to the, like, some of the pairs will, like some pairs will be stay half, like, in the yellow containers and the other half in the red, like, the burning red ones. And then presumably, I mean, the heat that is produced by the burning of the red ones, at least some of it will be transferred to those that are in the yellow ones, and they will be energized that way. So they will get some energy, even though it's not, there isn't much burning in it, like, or just, like a candle. It's difficult to prove it, that this actually happens. It's not easy to prove it. It's much more easy to prove it, using electricity. And it was proven several times in this channel, most notably in the DC over series from February 2024. Because then, using electricity, you actually see, like, like online circle, but that is kind of, it's supposed to be offline by any, by any standard or measure of that is known to human physics. Because, it's a broken circle. It's like a DC, DC circle with transformer, and, like, that is, and with two electrodes that are each in different container with liquid, and the two containers are made of, like, of clay, and they are placed on, like, a glass table, and so it's, like, obviously not a circle, but still you see, obvious and, irrefutable signs of electrical current, which is amazing. But this is, it's not, it's not a new, like, very, fresh news by now, but it's amazing, and it's a very nice way to prove energy transfer. With heat, it's a little difficult to prove it, and I still search for, like, a way to prove it, decisively. It might not be easy. So this kind of, like, energy transfer that I now use, it's pretty much like standard. I always do it, like, when I work with crucibles. I didn't do it. I always do it. It's just, it lies on assumption of energy transfer, but not on the kind of, like, serious proof. Anyway, at least the first slide of the three is interesting. So let's watch the all three together. And the next step is, what I want is the next step is to, so in Ochel Bat Avon, like, now that we have so many big ones, big is like a relative. Like, I would say they are like size 7, like, which is pretty big. 7, maybe even 8, like, so it's pretty big. Again, on the scale of 1 to 9, which is 9 is the highest that is not visible by the naked eye. So, but we do want, like, more, like, to make it even bigger. And even more numerous. So what we will try to do is actually to work on the on the electric stove. It's much harder, of course, than the hot plate, but the problem is that, I need to kind of be careful that it will not overflow, because last time, I tried it, like, it's the overflow, created a mess. So, I need first of all to clean it, and then, to kind of, like, that's the problem, with electric stove. It's difficult to calibrate, because, unlike with gas, I don't have gas in, like, cooking gas. Unlike with gas, like, like, when you lower, when you lower the flame, it's still, like, it takes time for it to actually, to reduce the temperature. So it's like, it's more difficult to create, like, a feedback loop, but we'll try to do what we can, because, of course, this way we can transfer much more energy than, using the hot plate, and also using the flames. Okay, so let's take a look and see, what we have. Okay, 64 magnification. Like quite a bit here that, I mean, I'm not sure like what are they. Maybe we'll inspect it later. Let's for now keep it like in the 64 magnification, not larger, and aim for the very big ones. So this is a very big one, very nice, certainly not a dud. This is a 9, like this is amazing. This is amazing. Like maybe 3 times the radius of that one. I mean, it can be visible by the naked eye. So we see very big ones. This is very interesting. Not tremendously fat. Maybe we can make it fatter. I mean, you know, I'll try to like, also to make them fatter, like, you know, when working on the hot stove. The one they left is fat. They're relatively fat, not super fat. But yeah, I mean, definitely tremendous amount of like big ones, and also all sort of like those. I mean, suspected like the small ones. I'm not sure. Let's zoom in, but first let's, you know, just sweep, you know, with 64, just to get a hold of, you know, of the big ones, like of the majestic of the, you know, quantity, I would say, of the big ones. So this is also a big one. Nice, very nice. Okay, let's take a look. 150, 160. Sorry, 160. So at that, like, you know, resolution, I mean, we do see duds, like ones that are not, like, we're not sure if they are created or not, but the big ones are certainly, you know, they are not duds, definitely. So overall very good slide. So just, I mean, and like a quick look maybe with 64. It was one with 600. I mean, this is 600. אתם שומעים את המחיאות כפיים, זה ככה מגרשים את הרוכב מהנרכב, זה הדרך לגרש, זה הכישוף שגורם לרוכב להסתלק מהנרכב וככה להשאיר את הרובוט שהוא לא יכול לדבר כי אין לו מה להגיד, כי הוא בלי הרוכב שלו. שזאת המטרה של השכן. לגרום לרובוט להיות אילם, כי מי שרוכב עליו ואומר לו מה להגיד, יסתלק בעקבות הכישוף. זה המקום בו אני חי, זאת ישראל, מדינה כלא נאצי בזוי ושפל, מלא ביצורים בזויים ושפלים. בזויים ושפלים. Okay, so we'll see quite a bit of near-world, like, you know, in the 600 as well. So this is like, it's a nice one. It's a proper slide, good slide. Let's just take a quick look at the 2 other ones. לא יאמן כל פעם כמה הבזות הזאת. כמה, זה מלווה אותי כבר מאז תחילת המחקר פה. הפער העצום בין החשיבות של הדברים שאני מראה לכם במחקר לקהל צופיי, והחשיבות של הדברים שאני אשים, לבין הבזות של השכן, שהוא תמיד, זה לא רק פה, זה בכל מקום. זה התינופת של המין האנושי, עם גם המוטיבציות הכי שפלות וגם הטקטיקות הכי שפלות. פשוט, זה לא יאמן הפער הזה, לא יאמן הפער הזה. אפשר גם להבין מהפרדיגמה הזאת של הרמפולסטינסקין, של בוא נגרש את הקוסם, כדי שישאר פה רק הרובוט. אפשר גם להבין מהפרדיגמה הזאת איך מתייחסים לרובוט ואיך תמיד התייחסו אליו, ועוד אפשר גם להבין איך התייחסו אותם חלאות, לכם, ארגוני המודיעין של העולם, שיש לכם יותר בקטריה ואתם הייתם יכולים לקבל תרופה. אבל הטרפוד, המחקר הזה הוא כמובן בעקיפין, או אפילו די במישרין, טרפוד היכולת לקבל תרופה. שחשוב, שזה לא משנה, כי מה שחשוב זה להוציא את הרובוט אפס כדי להצדיק את העבדות שלו, לכאורה. המחיר כמובן לא מישראל, אנחנו לא יודעים איפה הרצליה במפה. הניקיון פלנטרי. הניקיון פלנטרי. Also, pretty much similar to the other one. Although, I mean, very good amount of large ones, impressive amount of large ones, very loud, even very loud. This is impressive. I'm saying we can maybe even use this one for these 3 lectures for the Colosseum. Maybe I'll store some of it on the side, because I might ruin it, and it's already good. So I'll just store the mixture of from these 3 containers in kind of like another container that will be out of the game for now and will be used as backup if we ruin it as we advance, because I don't want to get to the Colosseum immediately. I want to try to even improve on that, but maybe I'll ruin it. This happens if it's overflow or burns or all sorts of things. So in that case, let's keep a little bit of it on the side, so in case I ruin everything, we can still use this mixture for the Colosseum, because I think it might already be interesting enough, but to be used, to be pitted against all sorts of biological monsters that we should soon dig from all sorts of places here. This is even a better slide, because obviously, these are not dots. The small ones are amazing. We have amazing amount of small ones. This is actually a great slide. It's from the container number 2. It's actually a great slide, because we see a great diversity and also great quantity. Not huge quantity. We've seen even more impressive frontal trees in the past, as I said, but very nice quantity, very nice diversity, and also a hefty amount of the big battleships. I would say this is exactly what we wanted for the Colosseum. This is great. It's from number 2, container number 2. So I'll keep this at least part of it on the side to be used as this is one of the largest Neros that I've ever seen. Still category 9, but even high 9. So I'll keep it aside to be used in the Colosseum, because it's already been pretty much what we wanted. It's all. I want to try it even a little more, just a little more. But it's already great. This one is already exactly what we wanted for the Colosseum. Tremendous diversity, tremendous quantity, and although certain existence of the battleship that we wanted. These are exactly the battleship that we wanted. So we are ready for the Colosseum, but I will try something anyway. Maybe we can improve even on that, and maybe we'll ruin it. Let's, see what we get. There is even diversity in the fatness. Some fatter, some not. This is a very nice slide, a great slide. One of the, this is a great slide. This one is fat one. Huge one and fat one. Very nice, very nice. Okay, this one was particularly impressive. So let's take a look at number 3 now, one from container 3. 64 magnification. Very nice. I mean, you know, just for the first frame, very nice. Obviously not that, obviously these are like, you know, good ones, but I mean, after, you know, the first, like, you know, good frame, the other, you know, it's just murky. Maybe just too dense. Perhaps it's just too dense. Sometimes I place too much material. It's a shame because, you know, like I seem to be that there are many treasures here, but they're kind of like hiding in a very dense solution. It's from container 3 that, I mean, you know, was always like the more dense of the three. If you remember, number 3 was always the denser and still the denser, so it's difficult to actually watch anything. We just can't tell what's in it. It's too dense. I mean, the light is not passed. Sometimes it passed, like now here. And again, I mean, this is actually nice. I mean, we have kind of, like, you know, very good reason to believe that it's actually amazingly rich mixture. Just, I mean, maybe I'll prepare another slide from just now. So I'll do it. I'll probably just, you know, I don't know if I'll take a video of that, because we already have enough evidence to continue very surely, like in our progress towards the Colosseum. But maybe I'll just take it like after we finish, you know, now. So okay, well, I will finish now. I will take maybe another, you know, sample that is thinner from container 3, just for curiosity. I'm not sure. I'll just, you know, take like a video of that. Maybe just you know, just take a quick look for curiosity, and then again, I'll try to improve on that using the hot plate, either the hot stove, the electric stove. Maybe, you know, we'll get like a great surprise, and maybe just we'll ruin everything. Anyway, we'll have what you already had, like, you know, in the side, and then we can commence not immediately to the Colosseum, but first, like, just watch microbes, like, you know, first, you know, just like, you know, just inspect at least two or three like mixtures with microbes, and not only microbes, but also all sorts of creatures that are even bigger than microbes. For that, we need to prepare like the petri dishes. So I didn't find, like, the only petri dish that I had that was clean, relatively clean. I had many petri dishes in the past, but I mean, they are done, and I have now nothing. But what I did find is actually a closed, like, mixture. This one is from like at least 18 months ago. It's kind of like locked between two petri dishes, glass petri dishes, which is the recommended ones for our purpose, and sealed with silicone. So it's like from at least 18 or 20 even months ago. So first of all, it's really interesting to open it and to watch under the microscope what's inside of it. Maybe this, I mean, it's like airtight, silicone tight, and 18 months old. I don't even remember what I placed in it, so it's going to be interesting. And then I need to rigorously clean it as much as possible, so we'll have the petri dish to be used as a container. If it's very well cleaned, which might not be trivial, and not scratched, which might not be trivial, it can be used for microscopic work. From experience, I can tell you. I mean, it's not the good visibility as a proper slide, but still, I mean, if we want to, you know, to inspect like life form that is pretty big, I mean, we cannot use the microscopic slide because they just crawl outside of it. Again, we don't want them dead. We want them alive, and that's why it's called the Colosseum. We can use a microscopic slide and kill it first. That was done in the past many times, but it's not a real Colosseum. It's more like, I would say, like a feeding ground or art or artistic exhibition when they try to, you know, to clone the limbs. This was demonstrated many, you know, long ago. But it's not exactly what we want. What we want is actually, like, you know, to see how they handle, you know, how they live with each other. Maybe peacefully, maybe less. Maybe we can actually, you know, use the symbolic language in some ways, even though it's we have very limited room for that because of the, you know, the microscopic environment, like the environment of the microscope, which is kind of like gives us very little opportunity for symbolic, to put like symbol around it or on it or in it. So we'll need kind of like, you know, artistic innovation, I would say, or engineering innovation to to try to manipulate the symbolic language to maybe give specific commands to the neurons, like maybe to attack or maybe to enlarge the life forms. I mean, both can be very, very interesting. And we also have the issue of energizing, which is, it's something that I've never, it never really, again, it never really actually. I mean, maybe I've never seriously proven that under the microscope, like energizing under the microscope, it's still kind of like a goal, like that was never actually materialized, like to prove energizing, but to do it under the microscope, so we'll actually watch the neuron and not energize and then energize. This is something that was never done. If we are able to do so, it might be extremely interesting. So that's it for now.